Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 8 of the February Daily LeetCode Challenge, and as you might have guessed already, from the last 2 or 3 days we are having questions on hashmap. Okay, for the first 5 days we had questions on arrays, and after that we are having questions on hashmap. So I guess this is the third day that we're having a question on hashmap. Okay, it's a very nice question. This is kind of a question where you will be given the functions, multiple functions, and you will have to design the whole code for that. Okay, so you're basically given a whole use case, and you are given multiple functions where you have to enter your code. Okay, this is one such scenario. Remember, this kind of scenarios also are common in your interviews. Okay, I mean the online assessments. There you see normally what happens, you are given a single function, you have to enter your code in that. Okay, but this is not the case. Okay, here you will be given not just one function, multiple function will be given, and you have to basically like design a whole class, I can say. Previously we were designing just a single function, now you have to design a whole class. That is the difference. Now coming to this topics here, it's question 32349, design a number containing system. Okay, number container system. So what you are given is, you will have to basically design two functions. Okay, now what is happening, just see the input here. Okay, see, just know one thing, that I will come to the question, but just know before that there are going to be around 10 power, okay, see, at most 10 power 5 calls will be made in total to these two. Okay, in total, that is, there are two functions, change and trial, fine, and in total to both of them this many number of calls will be made. And if you see the individual value, that is for index and the number, the individual values are going to be in the range of 10 power 9. Okay, so now let's see what the question is. See, design a number container system that can do the following: insert or replace a number at the given index in the system. This is pretty simple, because inserting and replacing, these are very simple stuff, right? We know, like in an array, if you have like the index, you can always replace the value, you can always insert the value, right? This is pretty simple. Okay, this is not the challenge at all. The next thing, if you say return the smallest index for a given number in the system. So what you have to do, if you are given a number, you will have to tell in which all indexes the number is present, and among them which is the smallest one. The smallest one you have to return. Okay, now how to do that? Because if you see, there are going to be 10 per 5 calls, so obviously it will be very difficult. Let us say you have a 10 power 5 array. Okay, array of 10 power 5 length. In that, you are going and searching, okay, for a number where it is present first. That is going to take a lot of time. I'm telling you very frankly, if you design a offline solution for this, you are going to reject it. I will say that. Okay, now let us see how to do that. So remember, the challenge here is this part, not the first part. The first part is pretty basic, everyone can do that. The challenge here is this. Okay, now how can you tell me how to do that? So see, I'm not going to in detail of anything. Okay, this is a very simple question, so I can directly come to the topic. So can you quickly tell me how you can do it? Let us say you have array. In your challenge here is that, okay, we will have to, if you're given a number, you have to tell what is the smallest index in which this particular number is present. Okay, if the number is not present, you have to return -1, as they have mentioned here. You have to return that -1 if the number is not present, but if the number is present, you have to return the smallest index for that. How to do that? See, the most easy solution that you can think of is going to open, where you can start from left, go towards the right. Wherever you see that number for the first time, that will be the smallest index. Okay, but that is going to take often time. Okay, that is not something that we can, that's very high, right? That's very high number. Often is not something that you can expect to see. Here the time confidence is very high. Okay, if you see, it is 10 power 5 calls, and the value is going to be 10 power 9. Okay, see, that means the final number that you're going to have, okay, is going to be in this range. Okay, as simple as that. So yeah, if you're having array, then don't expect, that is, let us say you're finding the last element, so you have to go from 0 to 10 power 9, basically. Remember that, in a single array, since the number is going to be like this. Okay, so see, there are two cases. After seeing this, what multiple people will think is that, let us create array where for every index we have a value. Okay, that's for array, right? And then we can replace the value, insert the value on that. Okay, but if you do that, what will happen is, see, the array that we're going to create in that case will be 10 power 9. Okay, the length of that will be 10 power 9. Okay, why? Because the last value, okay, is going to be in the range 10 power 9. Okay, so let us say we have to find the smaller index for this value, so you'll have to at least travel 10 power 9 values, 10 power 9 indexes to come to the last index. That is going to be very, very high. So definitely having array is not something that you can think of as optimal solution. Remember the same case we saw yesterday also. Yesterday also there was option to create array and solve the question, but creating array would mean that you are compromising a lot on the optimization part. Okay, that is not the optimal case at all. Okay, so how to do that? See, I will discuss. Look, let us go to this particular function first, and maybe then, after getting a picture of this, we will come to this part. Okay, let us go for that. So first thing is very clear. We cannot create array for this, because creating array will mean that, okay, we have 10 power 9. Okay, we'll have to allot a space of 10 power 9 in the worst case, which is going to be very, very high. Okay, so we can reduce that by using a hash map. Okay, let us see how to do that. Okay, now this is the init function. What is the init function? It's basically a constructor. Okay, you might have learned about constructor in your Java and C++, and similarly in Python we have an init function. So these are the two things that we're creating. Okay, self.array. Instead of creating a array, okay, that is a list. Okay, remember what is a array list? Array list means that the length is fixed. Okay, for each index there is going to be a single value, right? But as we saw, it is the final value and index that we're going to get is going to be 10 power 9. Okay, so that if we create an array like that of range 10 power 9, it's going to consume a lot of space. Okay, so we'll not be doing that. That's why we are just creating hash map. In this hash map, the key will be the index and the value will be the number. Okay, so using this hash map, basically we are trying to simulate the way a array works. Okay, the advantage here will be we can only allot a space to the number which is appearing. Okay, if it is not appearing, that is there is no meaning in allotting a space for that. The same thing we discussed and implemented in yesterday's problem also. Okay, now next particular challenge is how to find the smallest index. Okay, if let us say we are doing this part, but how to find the smallest index, that is for a number among all the index in which it is present, how to find the smallest index. Okay, some of you will tell me like what a heap. Remember, heap is okay, it's a okay decent solution, but just try to think of in this way. Okay, heap is a good idea, I agree, like heap is something that we will implement, but think of this scenario. Okay, let us say you have a number, and okay, let me just write it and show it to you. Okay, let us say you have a number 3. Okay, and it is present in let us say 4 places. Okay, let us say 77, 56, okay, 933 and 12. Okay, now these are the ones. Okay, you are creating hash map. So what will happen is hash map will keep this value as the first value. Okay, now what happens, here we try to replace this number now. Okay, we try to replace this number now. Okay, now in the index 55 we replace 3 with 4. Okay, what is happening now in the index 55? Okay, we are replacing the number 3. Okay, we're replacing the number 3 with 4. Okay, now after doing that, how will you change this hash map? This hash map is showing 55 as an entry here. So in order to replace this value, you have to basically do O of n search. Okay, you'll have to do O of n search among all the values present in that particular hash map. Okay, heap. Sorry, not hash map, heap, in the heap. Okay, so how to sort that? See, basically heap will only keep the smallest value in the front, that is this value, and yeah, there is only thing that you can get guaranteed from heap. Okay, heap will only have the smallest value first, rest of the values need not follow any order, right? Now in order to search for this value, we have to basically do open solution. Okay, open search, that is the thing that we want to avoid. Okay, so the only solution that we have is this. Okay, so there is a topic called sorted set. What it means, see, it is a set, it has all the properties of a set. In addition to that, it is also sorted, that is whatever values you're inserting, you will always find them in a sorted order. Okay, this is something that we're going to try now. Okay, I will give this link, maybe it's a geeks for geeks link, you can come and read about it. Okay, this is something that is going to satisfy our best case here. Okay, this is the best thing that we can use in this particular scenario. So what are the advantages here? This is the main advantage here. So what will happen is, if you want to remove something from this set, instead of doing off and implementation, you can basically do a log and implementation. So the internal implementation in this is going to log and time in order to remove a value, okay, from this set. That is something that is of very much use to us, because if you see, the challenge that you are having here is it is going to take off and time if you are having a heap or a simple list or whatever it is. Okay, heaps, you cannot have a simple list because obviously you want the smallest index first, right? So obviously you will think of a heap. Heap is a good idea, but the only challenge that will come is that, let us say this particular 3 is changed to 4, so this particular index you'll have to remove from this particular heap now. Okay, how to remove that? This is not okay, heap will only have the smallest value in the 0th index. Okay, rest of the values need not be in a particular order. Okay, so you'll have to do open search, find that value, remove that value and all that. Okay, again remember, if you're removing a value in between the heap, then the heap implementation is getting spoiled. Okay, it affects the data structure of the heap. So again, that is not a good idea. For that reason, the best thing that we can do is follow a sorted set. What is that? I will tell you that. But the best thing what it is, this, the discard part. Okay, see, add part everyone knows. Okay, add part everyone knows it. Okay, even in heap it is log n, basically heap insert will take, okay, log n time. But this is the best part. See, heap pop will always pop the smallest element. That is not something we need. We need this part. We want to discard particular value irrespective of where it appears. Okay, we want to remove that value and that will take log n time. Okay, that's why we are going to implement this. Okay, so see here. Okay, let me remove this part now. I hope I understood this part now. See, yep. So this array here, we are going to store a key. Key is going to be the index and the value is going to be the number. Okay, this is just like it just, we are trying to implement a list using this particular hash map. Okay, next, now comes this part. Okay, the smallest index will tell me, if you pass, the key is going to be a number here. If you pass a number, okay, the value is going to be a set. Okay, the value is going to be a set of the indices in which this number is present. Okay, I will again repeat, the key is a number, the value that is going to return is this. Okay, a set of indexes. What are those indexes? These are the indexes in which this particular value is present. Okay, which has this value. Okay, as similar to that, which has this number. right? Which has this number. So among all of them, we have to return the smallest one. Okay. Since this is sorted set, always the smallest index will be there in the 0th place. So we'll have to just return the 0th place of this set of indices. Okay. We'll come to that. First, let us talk about change. In the change, what we have to do, we have to go to this index and we have to change the value to this number. Okay, if some other value is there, that will be discarded. If there is no value, this number will be introduced. Okay, there are two cases now. For the first case, let us say if index in self dot array, that means this index is already present in our self dot array. That means there is already some value in this index. Okay, there is already some value existing. So what I have to do, change entries for the existing number. Okay, now existing number is equal to self dot array of index. Okay, for this index, what is the old value present? I'm calling this as existing number. Okay, now what I will do is in the smallest index. Okay, I will pass the existing number. Okay, this will give me set of all the indexes where this number is present. Okay, among them one is going to be this index itself. Okay, among them one is going to be this index itself. So what we'll do in that set, discard index. Okay, remember this will give me a set. This set will contain all the indexes in which this number is present. Okay, among all those indexes, we are going to remove the current index. Okay, this current index should be removed because what we are doing in this index now, this new value will be introduced. Okay, so the original value is removed. So for that reason, from its set, you'll have to remove the existing index. Okay, after that is done, what I have to do, see, now this is the original part. Okay, what we are doing, we are allotting the new value in this index. This new value will be now allotted to this index. Next, we will go to self the smart index of this number. Okay, this number, and in that we are adding the current index. Okay, since this particular number is now present in this index, so in its set we are going to add this index. Okay, as simple as that, right? Now let's see how to do the find is going to be very simple. Now see, if the number is there in the smallest index, there is a point number 1, and if see what it means. First of all, can you tell me what it means? It means that in our smallest index hash map, this number is there is the key. So for this key, what are the value? The value is going to be a set of indexes in which this number is present. But so remember, it is a set, right? So we are just checking whether the length of this set is greater than 0 or not. Okay, because sometimes see, after this it could happen, no, that the set itself is having a 0 length. So we are just checking if the length of this set is 0 or not. Okay, greater than 0 or not. If it is greater than 0, then return this set, the 0th element of this set. Okay, return the 0th element of this set. Okay, just see, this is the set and we are returning the 0th element of this set. Okay, if this is not the case, okay, let us say this number itself is not present in the smallest index, or the number is present but this number is being discarded, that is this number has been replaced sometime back. Okay, so there is an entry present, there is a key present, but the length is 0. Okay, in that case, what we have written -1. Okay, as simple as that. So yeah, and this was the solution. Like, I've tried my best to provide you all the comments and okay, everything that I can. I've tried my best. But yeah, this was one of those questions. See, again, here it's implementation part is not that difficult. Remember that. But the only thing that you have to analyze properly is these parts. Okay. So don't see just one function and decide on the solution. Go through whole thing and come up with multiple cases, like I showed you. Okay. See, here many people think that, okay, let me use a heap. Okay, because that is the best thing that you can decide on. Okay, because you want the smallest index. But remember some of the cases that can happen, because the change or replace is possible. So there can be a case that you are changing the index, but how you're going to go into the heap and change the, okay, remove the values now, that is something that you have to decide. Okay, that will help you to come to optimal solution. And that's why we are using this, okay, sorted set concept. In this concept, okay, it has two advantages. It can act as a set, at the same time it can act as a sorted list. Okay, both advantages are there. And the best part is that we can remove any value in that set, okay, in log n time. Okay, normally if you use a list or a even a heap, by the way, it's going to take off and time. Okay, remember one more thing, in a heap you are not supposed to go and delete any value as such. Okay, you can either use the heap push or heap pop, but you are not supposed to go and delete any value in that heap. Okay, which is neither max not min. Okay, you're not supposed to do that, because that will disturb the heap structure. So the best thing that you can use is this particular sorted set. Okay, so how to import that, I've already mentioned here. You have to import in your local. If you're trying this, you have to do a pip install for this, pip install this particular, okay, library, and then you have to import it. Okay, from sorted containers, import sorted set, and that's what we're using here in our default dictionary, right? So yeah, and that was all for this particular video. If you like my efforts, if you like the quality of my content, please do subscribe to the channel. This really gives a lot of motivation to continue further. See you tomorrow. Thanks a lot. This was my 109th video. There are much more to come. Thanks a lot.